there will be some intro sessions for you, like about big data and comparing with the enterprise data warehousing thing. How traditional systems are positioned now, how what big data is all about. This intro part will be covering up in first two classes. And why big data becoming more and more popular or inevitable choice for the enterprises. Everyone, either they're trying or they're getting into the big data to get the new bandwagon of the competition, right? Those things we'll discuss that. And coming to the actual content, this is what we're going to spend. So I assume that we start from the ground zero, and I'll spend enough time on the file system, and there will be working sessions for you, hands-on sessions for you, and also we'll see the Hadoop framework here. These two are the pillars, foundational pillars in the Hadoop framework, and there are some jargons inside each of this framework. So you must be aware of these. You must be completely aware of the high level, at least high level, the programmatic aspects of these two frameworks, in order to gain the essence of other frameworks, because the rest of all depends on these two. These are the core. We could call as component, but component is a small word for this thing. Core, core frameworks inside the Hadoop platform, right? So these are the things I would like to discuss about. As you know, Hadoop was built on the Java, and each one is a daemon inside the Hadoop platform. Each daemon has a responsibility, and there is a handshaking nature, there is interfacing nature in each of the daemons, and that part we'll see. What are the fundamental concepts around MapReduce, how we can write our own MapReduce thing, how we can extend it, how the scheduling happens, those things we'll discuss it. So how these two are correlated together and accomplishing the big data challenges, those things we'll see it here in the first week of the course. The second week, I would like to touch upon the popular subsystems in the Hadoop platform. I'm calling Hadoop as a platform because initially it evolved as a framework, but now more and more subsystems are being built based on the Hadoop basic frameworks like HDFS and MapReduce. So with that essence, you can call Hadoop as a platform because it is supporting many other subsystems inside of it. So with that aspect, I'm calling it as a platform. And many people call the Hadoop as ecosystem because they together they address wide variety of business challenges. So I'll be touching upon the Hive in the views of warehousing thing, and the pig in terms of ETL aspects, and Apache HBase that we look into it in terms of as a data repository or data store. And there are other popular ecosystem subsystems called Apache Scoop. This is for data integration or bulk data loading at a framework. You might be wondering about why we need a separate subsystem for a data loading. Why can't we accomplish with simple tools? You realize the power of it once you see the land mass, what we're dealing with this. Why we need a sophisticated data integration framework to deal with these challenges. And then the Flume. Flume is another type of data integrator. We are calling it data collector. There is some thin difference between the Scoop and Flume from the fundamental aspect, and each one evolved as a independent framework, independent, highly configurable frameworks. So we'll look at these the differentiating factors in these two frameworks. And finally, gone are those days that you have to open the command prompt, log into it, remember all the commands. So I'm talking in terms of if you're completely unfamiliar with the UNIX model or Java, if you're not comfortable in remembering the list of commands, those things. So there is a way. Hadoop not only for a development fraternity, you could be very well a business analyst, or you could be very well like a architect. It doesn't need to get into coding level, but you would like to play around with the UIs, and much of the jobs can be accomplished. So Hadoop now got Apache Hue. That with that now you can see what many of these subsystems can be managed by the Apache Hue. That also
so if Hadoop means you have to learn all these 6 things, right? Is that what you're saying?
Yeah. See, that is the reason you call as a Hadoop ecosystem. The reason the term being used is that each subsystem or each framework has its own purpose, but not necessarily that when you are looking for a career career enhancement or a new job in these areas, you might end up working with one or two or combination of 2 or 3 like that. But at least at an awareness level, you should have some understanding about these frameworks. But somebody might, if somebody is asking about Hadoop, so underneath all these frameworks are comprised in that.
Okay. So technically, so in our class, are we concentrating on one of these or all of these?
All of these. So what is going to happen is that there is a level of the knowledge you need to have in order to gain a decent position in the Hadoop world. So the ranking, 1 to 6 ranking is the priority. So I would strongly recommend you should have the topmost in-depth knowledge about Apache Hive. This is the kind of if you're going for a repair of some car or some automobile, at least you should have a cutting plier with you, a screwdriver with you. That is essential tools like that. In that sense, Apache Hive and Pig are the essential tools. You should understand it if you yourself be called as a Hadoop a developer or expert or an architect. These two essential tools, essential framework you should learn. The rest of all, depending upon your enthusiasm and the need, you can go into it. So the order like that, that's the same order I'm following it here.
Yeah.
Okay. But I'll be covering up on these things. So even the examples and even the samples or the real data, what I'm sharing with you, more centers around the first 2. Rest 6 will be upon your interest. I'll be sending you the use cases, but up to you to take up. Okay.
So will we get access for to the tool as well, or?
Yeah, you will get. So what is going to happen is that Hadoop is not a small one. So now, fortunately, many of the distributions in the Hadoop world, they're offering virtual machines. So you can download. If you look at my screen here at the bottom, I have a virtual machine here. It is from the Hortonworks company. It's a freeware. You can Hortonworks sandbox with them. So I'll be sending these links to you and also guiding you out. If you are not familiar with these VMs, I'll help you with this, how to deploy these things. It's pretty straightforward things. All that your laptop should be a good one. Should have at least 8 GB RAM, and you should have at least 100 gigabytes of hard disk, and at least should have dual core processor. If that is there, you can run a pseudo Hadoop environment in your laptop. With that we can start it. So this becomes a playground for you, like a sandbox for you, playground for you. But all the things what I was seeing it here, you can play in this thing. And also the examples, the material I'm going to share, that centers around this VM. So you will have hands-on exposure to these components. Let us say you can't do it in your machine. At least you should have access to your laboratory or some other means, so that you can run through this the material I'm going to share with you.
I should be able to do it because I have the same configuration, actually better configuration than what you said. So I think I should be able to do it in my system.
Yeah, wonderful. Okay. So that is the minimum thing. No, you could still go with a simpler configuration, but again, no, you will not, the experience won't be decent. It takes a sizable memory, sizable processing cycle. That's good. If you have already, that's good. Anything beyond what I'm saying is the end. It's a bonus for you. Okay. So that is the second week discussion. The third week, that's where the real the traction goes up. So far, don't get baffled with this. All the terminology here means so many subsystems. If you understand the basic building blocks here in the first week, if you focus on the basic building blocks here, rest of all is like incremental incremental building blocks only, and each one has a purpose to serve. If you get the essence of it, the core concepts around these things, syntax anyhow you can learn it. There are a lot of wonderful authentic materials available. I'll be sharing these links to you.
Okay.
So anytime you don't have to really worry about remembering syntax, the programming style of these components. Not at all. Anytime you can access the syntax, that's not a problem. But all that you need is that understand the essence of this subsystem and where to apply these things. That's what I will also emphasize more.
Sure.
So once we complete this part, the interesting part is the next thing. Hadoop actually it's there for a while, and it also evolving. So now Hadoop got into a new phase called Hadoop 2.0, and if you are closely following the industry, or if you are closely following the technology stacks around Hadoop, nowadays much of the distributions are releasing against Hadoop 2.0.
Okay.
It's an evolutionary path for the Hadoop. So Hadoop, though it's a very popular framework, it too had some challenges to compete or address. So it evolved over a period of time, and there are fundamental changes happened in the core level. When I say core level, these two. At these levels, I have been talking about these two are the core frameworks. At these core frameworks level, there are some fundamental changes happened. The way the architecture works, are the synchronized between the Hadoop and the MapReduce like that. So that part is essential for you. You should understand these things, because this is all for like, if in a realistic sense, kind of FYI, but you should have complete understanding about these things. But what you will be using in day-to-day life is this, either these components or the Hadoop 2.0 aspects. So we'll spend a good amount of time running good use case around the Hadoop 2.0. It comprises these components, and there's a component called yarn. With inclusion of the yarn brings up much more capability in the Hadoop world. We'll discuss that part.
Okay. So how does
So
the tool look like? I mean, I'm just is it a tool, or is it something like is it like Java?
Which one? Yarn, you mean to say?
No, in Hadoop in general.
Okay, Hadoop. Okay. So everything is there are two things for you, right? See, let me give an analogy. Maybe you can have that as a context. If somebody talks to you like Linux, what do you visualize? Do you visualize like Windows 7 UI, or do you visualize like back screen, getting into command shell?
Yeah,
What is your visualization?
Shell.
So that is visualization. Let's see, Linux supports both. You have, if you are going for a desktop-based versions, you could have a nice UI like Windows, or if you are very keen on using this as a server, you could completely end up playing with the command prompt black screens, right?
Right.
Similarly, Hadoop also like this. Node, this is the fact that Hadoop, it was written in Java, but it is a massive platform. No, you don't feel that you might not at some point you might not see the Java flavor also. Completely, it's on its own. Though underneath it's a Java framework only. So as we were discussing it, there are two flavors to it. You could completely get away with UI if you want to, or you could even get into the shell level and do all the things. Both things are there.
Okay.
Right?
Okay.
Hope am I clear to you in giving some analogy about this?
Yeah, yeah. So I just wanted to see, I guess I just wanted to see the UI or how that you said the Hive, right? Is that a UI
Right.
or is it something else?
Yeah. I can quickly show you that if you want. See, this is the VM. In the VM, what the CentOS version is running here. Let me log into it. Alt F5. Okay. If you look at the screen,
Yeah.
this is a Linux-based server. It is running with CentOS release,
Okay.
and there is a username password here. So that's all about it. If you're asking me about these things, nothing much in this. But if you see what is there in this one, so there are a lot of tools available. Let me take you to some. Okay, where is my hue? Okay, here. Got the password. Root Hadoop.
It is like a query submitting tool.
Yeah, this is like
Query submitting.
just give me a minute. Let me log into it and I'll explain you. Root. Oops. Okay. I think this is not the correct IP. Let me get the IP here. 92, 168, 232, 135. This is the correct one. Here. Root Hadoop. Okay. Okay. So, sorry, what was your question? I didn't, I'm sorry, I couldn't get your question. Someone was asking, a question. What is the question?
Yeah, it is a query submitting tool.
The UI, you mean to say?
Yeah, VM.
Okay, okay. Yeah, that's a good question. This is not just the UI. This is like, if you're talking about this one, Hue, this is like a front end for all these subsystems. I mean to say, you are right, it's a query submitting system if you're talking in terms of Apache Hive. But that doesn't apply for the pig. So look at it like this. If you are working with a database and let's say Oracle World, you know what tools you use to connect to Oracle. Either you can use Toad or some other. Even you can use it. You use inside the Eclipse plugins. In many ways you can connect to the database, right?
Yes.
So essentially, what you end up doing with database, either you write queries, or you write some PLSQL code, or you might compile them as stored procedures and execute there, or you can do some DDL things, right? Definition, build schemas around it. So many things you can do with a tool like that. So you are right if you're talking about Hive as a data warehouse. That's what you will be doing. You write queries, submit queries, do the work get done through query using query kind of syntax. But if you come to pig, it's all scripting. Just like visualize this pig like a shell scripting. You would like to manipulate the files, you would like to parse the files. That's what you do in shell scripting, right? Typically, you execute some commands, do that thing, close this program, open new service, and you start new daemon like that. That also can be done through the UI. And if you come down to Apache HBase, that's again with it's a data store. So typically, what you do, either you insert data or you retrieve data. But again, this various thing is there, one more data store is there. These two differ in their concepts, and even in its framework model as well. This is more of a SQL way, the familiar world we have been, and this is a NoSQL way. It's a new world, new way of dealing things, and this is for emerging challenges. And Scoop also you can integrate with the Hue. I mean to say, you don't have to worry about the lengthy commands for the Scoop. Ultimately, if you look at it, each one is a daemon here. That's what I'm trying to show. These are daemons running inside the Hadoop. Somebody calls Hadoop, it's comprised of all the daemons. That's the reason we are calling this ecosystem. And each one is dependency on something else. Nothing is independent here. Even if you look at the very core of Hadoop also, it depends on Java, it depends on some of the UNIX based offerings, you know. So that level of dependency is there. That is what we call as Hadoop, right? Ecosystem. Ecosystem is what? Each one is dependent on something else. Otherwise, you could call them simple frameworks. Usually, frameworks might not depend on many things. Hardly one or two dependencies are there. But here, if you look at it, there are many dependencies on each other. So we will not really need to understand all these integrated dependencies, but it is sufficient to understand such a thing is existing here, and this is for X kind of use case. This is for Y kind of use cases. That level of understanding is sufficient, and you should be able to get into this shell and start doing it. So what I'm trying to show, let me open up.
So just a quick question. So if we want to be able to do coding in Pig, should we know shell scripting?
Sorry, could you please come again?
If you want to, do coding and all in Pig, right? Should we know shell scripting?
You should know what? I am not getting the word.
Shell scripting, UNIX scripting.
Oh no. Yeah, shell scripting is not required. So I'm just giving. I was trying to give an example to you as shell scripting, but in the Hadoop world, you have to understand the Pig scripting. Pig is a scripting language. Oh. That's what I'm trying to show you here. So let us say, as we discussed, I'm showing earlier here. In the order of priority, at least you should get hands-on with the Hive and Pig, at least. That is the bare minimum things you should have. And each one has their own syntactical models. So what I'm trying to show here is that if you say Hive, so this is a daemon, this is a application that is there in the sandbox. So the moment we hit the command, right, so this path has been configured. So the daemon tries to connect to Hadoop. Initially it takes time to connect it. So now what you're going to see is that you get into Hive prompt here. Since it's a local and virtual machine, you see some delay in the beginning. Once the initialization happens, the rest of all will be pretty quick. So now the bash prompt has gone. Now we got into Hive terminal here. So now what are all commands? Now you should now the Hive syntaxes you should understand. Like if you are familiar with MySQL, Hive was built on the MySQL 3. So the interface for the Hive is exactly same to the MySQL syntax. So all the syntax would apply here. So this is to query database. If I want to use something, let us say use airport. Now we are getting into airport database. Now I say show tables. Okay, this is pretty simple. But what really is it like Hadoop? You might be a little confused, no? We are talking about Hadoop, and I'm simply showing the traditional way of things, no? Database, tables.
Yeah.
What's the big deal here? That differentiating factor is that. Let me write a simple query and show you that, and also show you the source for it.
Sure.
So far, you're looking this as a kind of you're visualizing everything as a database, it's structured one, database, tables, and there are some tables I have. Let us say describe, take terminal.
So describe is like select?
No, it is like a schema. It tells the schema of the table.
Okay.
Okay. Now let's select start from terminal, because it might be huge one. Let me take one first 10 records. Oh, it has no data. Okay, let me take another one. What is the other one? Country. Sorry, plane. Traffic could have. Yeah. So the little data is there. Let us see what the traffic table is. So it's a comparatively bigger table, lengthier table, and this is data showing it. But this doesn't really tie the knot. No, what we're talking about big data and the simple thing is just like the same thing. But if you really want to see what is there here, let me open up another window. Okay. Let me. Don't worry about these tools. They're pretty simpler and quite handy if you are coming from a different world. But if you're familiar with the let me open up these things. Okay, so what I'm trying to show is that okay, let us get into the slide. Yeah. So I just ran a query on a traffic table. You know this thing. I ran a query on traffic table, but there is no such thing called traffic table. If you are trying to correlate with SQL Server or Oracle or traditional RDBMS things, there is no such thing exists at all. All that I have is a simple text file. This is of 650 MB.
Oh my God.
So I'm writing query against a file here. So if you are very keen on understanding the file, let me open up. Let me exit from it. So what essentially means is that this file could have been of 600 GB or 600 terabytes, doesn't matter at all. As long as if you know the file structure, you can define a table like the one here and start applying the SQL knowledge we have. Writing queries, subqueries, do aggregations, all the SQL knowledge you can apply it. So our SQL query it takes the help of the MapReduce and HDFS paradigms and get the job done. So essentially, what is happening here is that in typically traditional worlds, this file has to be dumped into some table, and the table should have a structured
Yes.
schema.
Right.
And if there are deviations, you again go back to square one, alter the table. Those here you are they're not very compassionate here. No one complains, structure is deviating from the original one. You can keep extending the structure. Structure is flexible.
So how do you
And the cell
know
also flexible.
the structure of that file?
Yeah, that you'll get to know, right? That's what I'm trying to show. So I am there in the root. Let me log into which path is this practice fly. Let me go into that path. Okay, just look at it. I have files only, right? So what you do, like take head command, take and dump 2 lines.
Oh, okay.
I'm just printing 2 lines from the first. It's a big file. If you look at this file, if you see the file, it's a big file, 600 MB file. Let us take first 2 lines of the file. So this is structure. I have it, right? It's a first row is a header row.
Nice.
And there is data follows like this. So what I have done is that I just created a structure like this, and there are some little syntaxes that you have to follow to create a table like this.
Okay.
And then what is there is a simple comma separated file, CSV file, and these have millions of rows. I think this file has 10 million rows.
Okay.
The one you're seeing it here, and you're able to query it just like a SQL table. But in reality, there is no such table exist at all. It's all a simple CSV file. So the beauty is that I'm able to access as a file, or you can able to access the file as a table. Yeah. Moreover, if you want to do some serious scripting, data crunching job, you can rely on to the Pig as well. It allows you to write a syntax for it. The way it looks like, let me give you that flavor as well. Yeah, I'm going to spend another 10 more minutes, so we'll wrap up this session. So let's just hit Pig. Yeah. So we are getting into Pig shell. It's called Pig grunt. So here we are trying to work on the same file. So you say that a equal to load. You have to give it a path. You say that load give the path, say root practice and fly, and the file name 2008.csv, and you say that using pig store exact syntax. I also am not recollecting, but let me give that essence to you. Pig store separator. Here the separator is comma, right?
Yeah.
So if you this doesn't work. There's some syntax I just missed it, but this is the essence of it. So the same file what just we saw in a UNIX prompt, same thing you can load it into Pig. So once you load that into Pig, you could do like things like this. So let us say A is your data set. What you can do, you can say, excuse me, you can say for each say rec in A, maybe you can, there's a syntax starts here, just say that filter rec, you say matches. I'm just giving an algorithm, not actual syntax.
Okay.
filter record matches X, Y, Z, you say, some syntax. Then you keep on saying that, you say, this you will take it up into some y equal to like this, and you say, now you say that, no, excuse me, now you say y z equals to y dot count only which is greater than 10, something like that you do. So this structure you can build on top of it. So the file is same in both these three cases. Here you using that as a serious table. You can write all the MySQL commands. Here you can manipulate that thing as a UNIX file, or you can even manipulate the thing just like just like the way you deal. We handle the shell script on the files. You can deal with this. But underneath all these things, who is going to do the actual execution? That is the core frameworks what we are talking about it, HDFS and MapReduce. But again, you have flavor of working with the same file in different fashions. Sometimes our use case might be fit into the SQL model. Sometimes you can't do it in a single query. We have to do multiple operations: read the data, filter it, join with something else, do further more aggregations, that kind of things. Sometimes we can split the data into key value stores or data repositories. HBase is the one. Sometimes to get the data, we may have to scoop it from some known databases. Sometimes you have to get from a log files or some unstructured data, something like that. So each one has their use case, pretty much use case here.
Yeah.
That's what I'm trying to explain to you. Okay. So that is the essence of the Hadoop subsystems. Okay. Who are there in the call?
My name is Rajiv.
Okay, Rajiv. Is Durga joined?
Yeah.
Okay.
Sharda.
Sharda. Oh, okay. Hi.
Hi.
Sorry. I thought Durga also joined. Okay. Okay. So is it making sense to you, the subsystems? I'm just oversimplifying all these things here for the sake of simplicity. Okay. And actually I kept some slides to give some kind of understanding about this thing, but let us not get into it. Anyhow, we'll cover that in the class. That's not a big deal. But at the end, what you would have to take away from this is that at least you should understand, once we cover up the 4 pillars and then some beginning steps in the Hadoop, now you should start looking at Hadoop as a full-blown platform. If you look at the example I'm running it here, this one is running running under a single machine. My machine is hosting it as a service here, right? But in reality, this would have been a distributed one. Some of the daemons would be running in one machine A, some of them running in machine B. It could scatter across 50, 100, or be way beyond it. There is no limit for it, depending upon the requirement and the size we need to establish. So these daemons, they are the core daemons, and you can replicate daemons across the clusters here. And that is one aspect you should carry away before you close the course. That is what the administration part. You don't really understand, you don't really practice anything, but just watch just look at it, what are there in this Hadoop, how this has been built up. When I hit peak, what is happening inside? That's, you should understand it. When I hit peak, when I hit hive, what is happening inside? How this is whole framework is invoking itself from the ground zero. That part you should understand, and that will cover up in the administration part. And I will be taking 2 sessions around this administration part. But in my emphasis more on these 2 things. You should have thorough understanding about the first two at least, and then you should have the evaluatory path in Hadoop 2.0. That becomes your
How many sessions do you anticipate these things will be?
the
Both those slides, yes, 4 and 5.
those slides, right? These two will run for 2 weeks.
Okay.
Because you need to have good hands-on exposure in these areas.
Right.
So session might be for a day or two, but no, I'll pursue to go through some of the use cases I'll be sharing with you.
Okay.
You have to try on your own. I'll be helping you if you have any issues in that.
Yeah.
That's all I would like to cover. But anyhow, if you want, I can share the slides also. Not a big deal. We'll see. And before we start the first day, I'll share the links to set up the environment.
Yeah.
Set up this environment and get things going. So these are pretty simple tools, freeware you can download. I'll share the links to you. And once you have the environment, from day 3, you will be starting some samples and working with that.
Okay.
Okay. So that's all I would like to cover in the intro today. Sharada,
Okay.
you have any questions?
We need to know UNIX links.
Yeah, good question. You need to know little bit of it, at least to the extent of navigating through the file system. What you do in let's say this is Unix system, Linux and Unix, both shell is bash shell I'm using it.
Okay.
At least you should be able to say, look at the commands, look at the files, how to navigate CD, how to navigate between the folders, how to open a file.
Yeah, those simple things is okay, but in depth we need to know.
No, not at all. Not at all. Even for the extent, you could also look at Java. Do you need to have complete Java exposure? I'm not sure whether you came from Java background or not.
No,
If you're thinking in that lines of having Java, that's not required. That is a advantage if you have Java knowledge, but that's not required. But did you ever see me being looking for Java based commands? No, right? In the quick samples I just showed you. Right.
All you use
Yeah. So this is what the abstraction you're talking about, These are all the abstraction you're talking about. We're talking about abstractions. There is no question that, no doubt that the framework has been built on Java, but that is gone. The scope ends there only. You are not dealing with the relating the hive, designing, modifying pig. That's not the objective at all.
Yeah, Apache you're telling is a ETL tool.
I mean this one.
Apache Pig like ETL is a.
No. Don't categorize in that sense. My request is that it is more suited for the ETL kind of workloads.
Okay.
But it can be used for regular things also. But the terminal, the words I put it as a here is that the meaning of these words is that this is where the use case is being used, but not that it can't be used for other cases. It can be, but this will give you a quick understanding about this is much suited for the ETL kind of aspects.
Okay.
Right. So in our case,
the ETL, it is easy to know this pig.
No, not that. That's also not completely correct. The reason is that ETL is a big spectrum, the extraction, transformation, loading, each one has its own depth. And if you see a lot of tools, they are specifically designed for ETL, right? Take MicroStrategy or Cognos. They are pretty much age-old tools in the ETL space. If you are coming from data warehouse, Cognos is a very predominant player in the ETL, and there is a very robust system also. So that we're not talking about a pig as a kind of neither a competitor nor a kind of any challenge to the ETL tools at all. But what we're talking about is that if you have a big file and you wanted to crunch it to, you want to filter it then and there without understanding the file completely. So you are getting into ETL kind of aspect, not exactly you're doing this ETL thing, right?
Okay.
That's where I'm talking about. So then you can use its pig to crunch it. The one I was trying to show it here, right? This is the one I was trying to show. So that in that sense you are right. We are going to deal with in the ETL aspect, but you don't have to know about ETL basics at all.
Okay.
But pig is a generalized one. It's a universal tool for the data flow model. So if you look at pig, what is going to happen is that look at pig. It's a simplistic one. This is the actual syntax. Let's say if you have a file like file 1 and file 2, I'm loading it in A and B data sets. So I'm filtering it and then joining A, B, I'm getting C, D here. And then further filtering, I'm getting a data set called E. And then further processing, I'm getting a data set called F. And then you're doing some, in the F, this is actually a grouped one. It's aggregated one. You're doing grouping and getting count of it.
So
and
this
finally,
is the syntax?
Yeah, this is syntax.
Oh, nice.
So finally, I'm dumping into F. This is hello world program,
Okay.
So what takeaway, what you can get, what analogy you can get from this thing? This is like a data flow language, This is not a complete ETL, but it looks like ETL, right?
Yeah.
So that's where I'm coming from. So pig is predominantly used for data flow, but most often you can assign a name called ETL for the data flow. So that's where you spend up much of the time.
Like ETL is a loading utility.
You're right. ETL is a loading utility, but here you're not loading from nowhere. File already there like this.
You're storing like a file itself.
Yeah, we have a file already. Some other tool has created a file for us. Pig is not dealing with creating files here.
Okay.
File is already there. But what we are trying to do, we are trying to process the file and get some output. The processing is around, I have two files. I want to join them just like tables. Actually, there is no such table.
Okay.
We just have a comma separated files, X, Y, Z, TUV columns we have in these comma separated files. So in these two files, I'm going to join the files, do some processing. This is a very basic pig scripting. Okay.
Okay.
Okay. All right. So let us go back. With this, I would like to pause the session. Let me know if you have any questions. I'll also be sharing with you the basic UNIX refreshers and the Java refresher if you are not familiar with that thing. So that becomes a starting point for you.
Okay.
Questions, Rajiv?
No, I think I'm comfortable right now.
Okay.
So you said the total class will be how many days?
No, 5 days a week for a month.
Okay.
So weekends, I'll expect you to know if you are not getting much time in the weekdays, at least in the weekends try this the use cases I'll be sharing with you.
Okay.
Is it easy to learn?
My apologies. What is the question?
Is it easy to learn?
Indeed, I would say So let us quantify the easiness also. I don't want to confuse you with easiness.
Okay.
So, so let us say if I assume you that no, you don't have any programming experience, neither you have any inclination to learn new things. So how do you get away with Hadoop? But where, yeah, that's a good thing you brought up. But why do you need to learn Hadoop? Just look at this slide here. It just costs 1 minute. I'll just take a few more minutes. I'll just wrap it up just in 5 minutes. So if you look at this is the landscape for a 4 years old snapshot of the industry. Based on Hadoop technologies, so many other things are evolving here. So this I'm talking about ETL space, ETL and the business intelligence, visualizations as well, these two. There's a blurred difference in this. And even the structured database getting contributed to Hadoop here. And the infra and other things. So in each of the specialized areas, we're getting so many tools, vendors are there, so many product developers developing new products day by day. But if you look at the current scenario, so crowded and more of specialized categories have emerged. Name any category, let's say you want to do specific kind of analytics, there is a tool out there. You want to do specific kind of data load, there is a tool out there. If you want to do processing on a Windows-based log file, there is a tool out there. If you want to do processing on a specific Sun-Solris-based programming, Sun-Solris-based log processing, there is a tool out there. So more and more specializations coming up. That means Hadoop got a lot of popularity, and the people see this is a kind of a, at least for this current generation, and a panacea for many of the challenges the enterprise are facing now. So with this context, and it is not fair to expect everybody understand Java, UNIX, and understand the nuts and bolts of Hadoop. That's not going to happen. If that is the case, this much of popularity would not have come. Since you're seeing this popularity, so much crowdiness is there because it's quite adaptable, quite versatile, right? The easiness is coming up. So easiness is that. That's what I was trying to show. I was trying to show why this is not letting me to jump. Oops. Some service is down. I'll show you in next class. Something is happening. Okay. This port is not open. I think maybe something like that, or authentication might be failing there. It should let me. No, not allowing me. Okay, don't worry about these things. Some port change would have happened. So because of this popularity, unless it is easy, you can't really. Let us say, iPhone. Take iPhone. No, that is a more generalized one. Any novice user also can get into iPhone quickly. They don't have to worry about those things. System doesn't crash. It's all pretty reliable, durable hardware, right? Something like that. So in that analogy, Hadoop also become pretty much reachable software. And because of what? Because of I showed you subsystems, Hive, Pig, those things, become very easy to get onto the Hadoop and do serious use case around it. And moreover, this is where the business is seeing value from it, Till now, many of the companies using the analytics as a reporting tool are doing some little bit of OLAP kind of things. But once they have Hadoop in their organization, they're going beyond and getting into business analytics now. So far, the two shaded ones you see, these are all more of aggregated analytics. They tell you what is there, what is the essence of it, but what meaning hidden in this data that you can't get from this aggregated analytics, summary analytics. For that, you have to go into the business analytics. There you do some classification or clustering or prediction here. That's where Hadoop bringing value in the organizations here. And with that, the complexity also arises actually, that you can't deal with this in this traditional way. That's where, that is the thing. So to solve this, so when things become complex, adaptability will come down, right? To have a bridge between the complexity and the business value, because there is a value, but it's again too complex to handle it. And many tools have come up, and they made it easy that if you, wherever you are, you can stay there. Let's say you are a BA, you don't want to learn new things, you can stay with the Cognos tool, connect to Hadoop, do your job. Or if you are a MicroStrategy person, or if you are a Tableau person, a Pentaho person, Pentaho expert, stay wherever you are, you can connect to Hadoop and you can do the job there. But what is the power you're going to get is that you can deal with massive data.
Yeah.
How it is going to do, it's all the Hadoop headache. You don't have to worry about Pentaho or the Tableau. Tableau can just submit a job to the Hadoop. Hadoop will take care of process the data. Right? So that's where the value is coming in. That's what, when we want to quantify the easiness, that's where it is. So it is more, why this, otherwise you could very much get a question, why we need so many frameworks here? Why should we get away with one or two? That is to easiness also. If you're comfortable with Hive, you can accomplish everything with Hive. Or if you're comfortable with Pig, you can achieve everything with Pig. Or if you're okay, you can learn both the tools. So depending upon your orientation, you can pick and choose. But anything can be achieved. Nothing like that. This is exclusively for a warehouse, nothing like that. But this is meant for a warehouse. Nothing that, not like you can even do data processing as well. What Pig can do, Hive also can do to a certain extent. Vice versa also true. Hope I have given some clarity.
Yeah, is there like a developer, this course like developer or admin?
Yeah, that's a good question. I assume that not yeah, developer that way, developer only, because we are looking at individual frameworks. We're getting into code level, right? In that sense, you are right. We look as a developer. But once you get to know how the tool can be used, then you can get on to Hive and run the queries.
Okay.
That way. But you should understand it, right? Tomorrow, the reason, because unless you go into syntax level, how do you understand at least you should understand the structure of this framework, right? And then how each framework is positioned here. Once you're aware of it, you don't have to remember the commands, anything. You just have to come down to the UI, and everything is a graphical thing, just like having one single product for all these subsystems.
So on a daily basis, a developer usually uses Hive and Pig on the UI?
That's a fundamental thing, right? See, if you, let's say, if you are a data SQL developer, or if you are a data warehouse person, what you do and what you do daily, more or less you work with some data loading, transformation, and writing queries, right? That's what you do. So ultimately, we're not talking about, we're talking about data, big data, right? So big is a word, big is the attribute there, but you're dealing with data only. You have to look at the data, do some processing. Otherwise, what is the meaning of having a big framework around it?
Yeah.
So Hive and Pig are the essential things. You should understand it. But how about your comfortness, Sharda? Are you comfortable in the syntaxes, or?
No, actually I'm learning Teradata.
Okay.
I'm just giving interviews also.
Okay.
That's why I know little of database.
Okay. So if you, for people who have at least basic knowledge about database, you will love this Hive.
Okay.
And it can happen that you can completely stay with Hive only all the time. But
I'm just for the administrator. That's why I'm asking. Is it for the course for developer?
No, administrator wise, what happens is, administration is a big thing in the Hadoop. That itself takes 1 month. if you really want to discuss everything. So
Okay.
in this course, I'll just give a flavor of what admin activities are, and if needed, how you can get into troubleshooting.
Okay.
This course may predominantly try to familiarize with the subsystems here, subsystems and main system, not try to explain the architecture, the administration part of it, how to set up Hadoop. Those things are not, we're not touching upon these things. That itself is a very big thing. In fact, it takes 45 days if you really want to discuss everything on the administration part.
Okay.
Okay. So shall we take a pause now?
Yeah.
Okay.
If you have any questions, I have to jump on another call. If you have any questions, you can feel free to reach out to my mail ID. I'll share whatever I could.
What's your mail ID?
Madhu.s.
Okay.
.trainer.
At Gmail?
Yeah, gmail.com. Yeah.
I'll send you a test mail.
Okay. So hope this this clarified your questions. Hope you all soon in the coming sessions. Thank you.
Yeah.
Okay.
Thank you.